Hello, everybody. Good morning, Europe. Good afternoon, Asia Pacific. Here is Daniel speaking from Solicam International Support Team. And I want to say welcome and thank you for joining us today and on this very important webinar series, which is about basics of post-processors. I can see many people joining us today, and it shows us how important actually the post-processors are. I would just like to say a few things about the post-processors, as many of you are just going into this subject. I would just like to say that the post-processors is one of the most important factors in CAM business. As you know, the customer satisfaction basically can be measured by the how good the post-processor is written. Basically, at the end, it is about is it work or not at the end for the customer once he run it on the machine. So it is very important that we always deliver it, the high-end post processor together with our CAM. We can be the best CAM in the world, but if we don't deliver correct post processor, our customer will be not happy. So this is why we organize this webinar, which basically will teach you how to write and how to modify a post processor, so you always have a happy customer. Yes. I hope you can all see my screen. Just let me see this. Yes. So basically over here, I just opened this main page, as you all probably were able to see it before. And what I want to say is a few words about this webinar itself. Just a moment, I think we have some small issues. Just a second. Okay, I have to click on show screen. Okay. All right. So as probably all got the invitation over here, and I just want to say a few words about this training course. As you can see, we organize actually the training. It's not like a standard webinar, so you basically can interactively go through these sessions. And it is very important that you all have installed the Visual Studio Code. It will not be so important for the very first training session, but for the very next ones, it will be very critical to have it also installed. You can basically click on this link over here, which will guide you towards this PDF, which in detail describes how to install the debugger and the post-processor editing tool, where to download it, how to install the necessary plugins in order to work with. Also, I have prepared here the agenda of this post-processor training course. And over here we have all the subjects that we will pass through. And one of your first questions might be, where we are once we pass all this training course. Okay, so first, regarding to agenda, it consists of all the subject that GPPL or General Post-Processor Language, which is the internal language of Solicam for writing post-processor, consists of. Okay, so I would say there's no basically the difference between the 3-axis post or the most advanced 12-axis mill turn. You will still use the same functions as you can see in front of yourself. But we wanted to do it also a little bit different. We put like a six training sessions, which on the very last 1 or 2 we will see how the thing goes. We'll also start defining everything from the really scratch for the 3-axis FANUC post processor. Okay, which will be very good first step towards the post processor. So you can see and feel what the post processors really are, and it can give you a really good base when you start to modify other posts and other codes. Okay. Today, together with me, it's also Vukasin Nikolic. He's our application engineer working in Solicam support team. He's modifying post processors on a daily basis, and he will basically guide you through this training course. I'll make him now the presenter. And for all of you, you should know that this webinar or training, it's all the time recorded. So after each session, you will receive the training recordings, also the contents of the webinar or the training again. And if you have any further question, we can also unmute you, and you can also raise the hands in the toolbar of the GoToMeeting. But you can also chat us there. I will make sure that at the end, Vukashin receive all the questions, and maybe by himself or by together, we can go through it. So Vukashin, I will now make you a presenter. Let me find you over here. Okay, a few moments. Okay. Okay, Vukashin, you're now presenter. You can share your screen.
Okay, I hope everybody can hear me.
Yep.
Thank you, Daniel. Welcome everybody. My name is Vukashin. I will be your presenter and I will be guiding you through this course on the matter of these 2 weeks. Hope everybody is okay and safe, and we can start off. The first question that is asked is why solid CAM or any CAM needs the post processor. As you all know, each machine requires a different NC code format depending on the model of the machine, the type, the control unit model, and because of that we need the post processor. You can see here that the Heinlein FANUC and apt output and Gcode are very different. So there is no universal Gcode that can run all the machines. Because of that, we need to format it according to our machine, so everything can move in a safe, consistent, and predictable manner. Now, what is the path from the SolidCAM toolpath to the Gcode that we run on the machine? Every operation generated in SolidCAM has a pgen file in the background. It is stored in the temporary folder with an extension of pj, and you can find it there, and it consists of every action, coordinate, and move that describes the toolpath. So that raw data is something similar to the CL data that you can output in most of CAM software. It goes to the VMID, or the virtual machine ID. It represents the machine kinematics, machine limits, and the controller format. After the pgen data goes through the VMID, formats it itself according to the machine kinematics, it goes to the GPP file. GPP file gives the output the format it needs so the machine can recognize it. Basically, it consists of procedures and parameters that format the output, use the data that is given to it from the pgen and VMID to format the G-code we run on the machine. This formatting is done by us as post-processor developers, and it is up to us how it turns out in the end. Now, next step when editing the post processors is setting up your database, or how to set up SolidCAM settings for your editing of the post processor. The default location for post processors in SolidCAM is in the public documents, which you can see on the picture on the right. This is for the SolidCAM 2019. You can put all your post processors in this folder. They will show up in SolidCAM, but we recommend to create your own database structure. Why? Because of version control, because of better organization. You can split the post processors in any way you like, by customer, by machine, by type of machining, however you like. There's a protection of accidental data loss, because if you have everything in a default folder, you want to update SolidCAM, you want to uninstall it for some reason, you don't back up your public folder, you can lose all your post processors. Now you have to contact the reseller, or you may lose all your data. Just give me a moment to check the screen. Okay. Okay, sorry, I didn't realize I was sharing the wrong screen. Now, if you lose all your data, there's a problem. Because of that, we in our team have a offsite backup that is synced with the cloud, and in that way you can always keep all your processor in the same place. You can set it to backup automatically and you have no worries. And what I meant with the version control is you have created a post processor for the customer in 2020 version. The customer is satisfied, you have tested the post processor, you have the COM part and the G-code that was used on the machine. Now the customer is well and happy and working with that post processor for the next 4 years. SolidCAM 2024 comes out and he wants to update, but he is worried that his post processor won't work with the most recent version of SolidCAM. Now, how can you check that? You have the part, you have the G-code from the 2020 version. You just need to open it in the 2024, generate the G-code. If there is no difference between the 2020 G-code and 2024, you're all good. Customer is happy, he can continue working in the new version of the software. And if there's a difference, again, you have the right G-code, you have the post processor and the version it is working in. It shouldn't be any problem to update it to a new version. Now, the next is the recommended folder structure that we use in our team, and that has showed itself very good to organize and to search. The first level is the customer name. If you're a technical person and you don't know for which customer which post processor goes, you can start with the level down with the machine name. And in the machine name, you have for each machine its documents, post processor and machine simulation, COM part, G-code, and a miscellaneous folder. Documents folder houses all the data that you used to develop the post processor, so programming manuals and stuff like that. Post processor and machine simulation, like the name says, houses the GPP, VMID, and the machine simulation folder. A COM part houses the COM parts that were tested with that post processor and the machine, and you have G-codes for them. G-code houses the G-codes that were tested, and miscellaneous folder houses all the pictures, videos, and any data that was used when developing the post processor. Now, post processor, COM part, and G-code folders are split in versions, like I said, because of the version control. So you always have the backup and you have the most recent post processor. Now, I hope all of you downloaded the files from the invitation, and we can create our own database that we'll use in the training session and just to test this folder structure. Now, I will open the folder and I will create it in my data hard drive and make the folder GPP database. Now, the first level, like we said, is the customers. Now, let's say GPP trainees. I'm using the keyboard shortcuts to create folders, but you can always go into new folder or something like that, just to don't create any confusion. We can go like this. Now the second level is the machine. We can just pick any machine, let's say DMG, DMU 80. And now, following the structure, in the machine, we need post processor, COM part, G-code, documents, and miscellaneous. Now when I switch, let's first create post processor and machine simulation. Next is COM part. Create G-code. The miscellaneous and documents folder I won't create now because we don't have any additional files, but if you have, you can always do that. Now, let's copy the webinar content into the post-processor and COM part folders. Now we can just copy it like this. We need to make the folder of SolidCam version. I'm using the 2019 SP2 hotfix 8 for this series. So Solid 2019 SP2 hotfix 8. And now we can copy the post processor into this folder. Okay, that's it. Let's go back and copy the COM part. Now again, we need to create the SolidCam version. Okay. Now let's copy the COM part to that folder. It's okay. One thing I would like to do is to assign the Visual Studio Code as the default software for the GPP files. This will make this all consistent. Okay, you go to properties and here to change. I have already set it because I use it every day. Hope you all installed it and can change to it because we will need it later. So you can go to change. If it's not here, you can browse your PC directly to the folder where it's installed. Okay, now let's continue with the presentation. So what is oh, I want to go back, sorry. How to change the default folder for post processors? I've forgot to mention that. I'll need to open SolidCam settings. We can go to tools, SolidCam settings. And in there are three main folders where we change the directories. So the first is in user directories, user directory for COM parts. Here you set the folder for your part. So let's do that. Okay, COM part. Let's copy this path. Open SolidCam. You just need to paste it here. You can always go to browse, but this is the fastest way. The next thing is the default CNC controller. If you go here, you can see all the default controllers that come with SolidCam. Now, this is the default path. Let's open our folder. Okay, copy this path and paste it here. Now, nothing changed. You just need to click anywhere. It will update. If we had the machine simulation for this machine, we would change this location and set our location here. Now, if you go OK, and if you go open SolidCam, our part will be here, because you can leave the default path to the getting started parts, but you would need to browse every time you open something. This is the way you make sure you have the right part opened and you don't create any problems. Now, if you open it, we will see. Okay, hope you all have the part downloaded. Now, for this first presentation, it is not too important, but for the next, you would need the Visual Studio Code and the COM part. Now, let's check out what we have here. So it's a pretty simple part, but it will be great for our presentation. First is face milling, like always. Now we have two profile operations that are done like this just for the presentation purposes that you will see later. A pocket operation, center drill, and drill. So pretty basic. Now, if we check out these operations, we see that we have a pretty simple one. And how do we know what to change in post-processor if we want to make any modification on this toolpath? Now I will open the presentation again. And if you see these actions, there's the tool starting point. Now before this, there are machine settings and tool change, but we will concentrate on this operation solely. Now you have the tool start point, we have a rapid approach by Z, we have a arc lead-in, again a linear machining move, arc movement again, linear, there's an arc lead out, and rapid retract by Z. Now, how do we know what procedures or parameters are called from SolidCam for all these moves? Well, the most important thing in post-processor development and debugging is the trace statement. It formats simply just trace the procedures you want to trace and then the trace level. Like the description says, GPP will produce the trace level, trace information while generating Gcode. So everything that is going on in the background will be printed. Now, what will be printed exactly depends on the trace level. So we have the trace level 0. It prints a basic Gcode without any additional information. This you can run on the machine and this should customer get. Trace level 1 is most commonly used for debugging, and it prints the routine name that is used by SolidCam. So all the procedures that are used and what is printed from each of that procedure is shown in the trace level 1. And if the trace level is more than 1, maximum is 5, you will get, like you see in the picture, a lot of variables and a lot of information. Now, let's add the trace statement to our post-processor. Now, how to open the post-processor? You can always go to the folder where you stored it and open it from there. But I don't recommend that from a simple reason. Imagine you have a reseller at the client's place and he's sending you post-processors forward and back each half an hour. You can get lost which post-processor you are editing, and you can lose some time editing the wrong one or make a mistake that can crash a machine or something like that. So best practice is to open it directly from the VMID and the COM part. How you can do this? Open the VMID, go to open and open the post-processor. You can also go double click here. If you don't see this, if you don't have these options, you don't have these devices, you need to make a edit in the registry. Now, how to do that? Let's open registry editor. So regedit, open it. If you go to the current user, go to software. In the software, you need to find SolidCam. When you open SolidCam, find the version you are using, and then the folder CAM experimental mode. CAM experimental mode, you need to create a new dword 32-bit. I won't create it now because I already have it, but the name should be SUPERMACHIDIDOR. I will leave it here so you can write it down. So a new 32-bit dword. I won't create it now because I have already with this name. I'll delete it. So this value needs to be 1. That allows you to edit the VMID and to open the post-processor from it directly. Okay, I will close it. If you didn't catch time to write it down, you can always leave a comment. I will send it in a message. So we will open our post-processor. Now, if you have Visual Studio Code and you set it as a default software for opening GPP files, it will just open like this and should look pretty similar. Now, we wanted to add the GPP, but the trace, but let's first take a look at the GPP. It consists of procedures and variables mainly. Everything else are operators, some assignments. Now, what is a procedure? Procedure starts with the @ symbol, a procedure name, consists of a procedure body, and ends with the end P. So everything between the end P and the @ symbol, with everything in between, is one procedure. For a clean look of the GPP, we add these separators so you can clearly see where every procedure starts and every procedure ends. Now, let's add the trace statement. If we go back to the presentation, the format is trace, then you say what procedures to trace, a colon, and then the trace level, being it 0, 1, or more than 1. Mainly I use 5. Now let's open the GPP. So the format is trace, then you specify what procedures you trace. You can go with, let's say, just line, or you can go with all. That will trace the whole Gcode. Then the colon, colon, and the level. Let's start with 0 and see what happens. Now, you need to save the GPP after every modification, so it outputs correctly in the GPP in the Gcode. The marker that tells you did you save the file is this circle. So if you see this circle, it means that you didn't save the file. Same is with this number here or this dot here. So I will go Control S and everything disappeared. It means I have saved my change. Let's open SolidCam, close the VMID, and let's generate the Gcode. So we said the trace level is 0. When I generate the Gcode, just a regular Gcode that can run on the machine. Now, let's close this, go back to the Visual Studio Code, set the level to 1. Let's save it again, change to the SolidCam, generate the Gcode again, and now we see the procedures. And this is one of the most common questions. How do I know what comes from where? Well, this is the best tool you can use and the easiest way to see what is printed. So I know that the user and my username is printed from the startup file. Same with the tools. So from DevTool, we have all this printed. And one of the question is the order of procedures in the GPP file the same as the order that it is printed in the Gcode? The answer is no. As you can see, we have init post that is not shown in the trace one. It is the procedure that loads all the variables and traces them. So let's say first is start of file, then dev tool, start of program, and change tool. If we take a look at the output, start of file, but we have VMID info. Dev tool is correct, start of program is also correct, but then change tool is all the way here. So we have something in between. So don't go by the rule that the order or procedures is the same as the order that is printed. Now, we can generate the trace one for our toolpath and see what procedures are used there. Let's do that. This is the operation. If you go right click, Gcode, generate. Okay, let's leave the default name. We can see that all the moves I have listed in the presentation can be divided as a procedures. Let's focus just on the operation that starts with the start of job. All of these are setting the machine planes, resetting the compensation. So if I go back to the presentation, we can see that our operation can be shown as a sequence of procedures. So tool start point is the tool in the start of job. A rapid approach by Z is rapid move. Then we have a small line to approach, arc lead in, again line, arc, line, arc. Then we have the retreat by Z and end of job. The same is done in the opposite way for the other operation. So if you go now to our presentation, our code, you can see start of job, it's same. We have feed spin that starts the tool, but there is no move for that. Rapid move, then Z rapid move, line, arc, line. So this is how you understand what prints what. Now let's continue. And this is what you can see here. Now let's test the trace level 5. Let's see what we get if we print with trace level 5. I will go back the GPP. I will set the trace level to 5. Save the file. Let's go back to SolidCam. Generate the Gcode. And whoa, we see a lot of data. We see paths for the files, my username for the account, material for the iMachining, also what is printed in each procedure, but we see a lot of data. What are all these names? These are variables. And now you can say, what is a variable? Well, we have a definition for that, and a variable is a unit of data that may be assigned a value. So it's a named unit that has its name and the data that it stores. If you change what is stored, the name won't change. So you can change everything about it or what is in it, but the name must stay the same. Now, imagine a variable as a box in the FBI database. So each of those boxes has a unique name. They can store different data. Some can store audio tapes or folders, pictures, some video recordings, or I don't know, objects like weapons. Same is in SolidCam. All variables can store a specific type of data. We have 4 different ones. They are integer that hold the whole numbers, integer numbers, so no decimal points. We have numeric that can hold any number with decimal points. Logical that are only true or false, or we can call them Boolean because of the Boolean operators. And there are strings that can hold a string of characters with a unlimited number of them. And all of those variables can be defined as an array. Array is a more advanced type of variable. It is used a lot less, but the easiest way to describe it as a one variable, but it has levels. So imagine you can see in the definition there are indexes. So you can have tool name, but you can have tool name 1, tool name 2 in an index. So every number or index will hold the different data or the different tool type or name. We will show that later in an example. So how do you define a variable? Well, you can define, you can have system variables that don't need any defining, so they are loaded automatically. And you can have user-defined variables that we define by ourselves. Or all those variables can be local or global. Now, the global variables are defined in the init post procedure and can be used throughout the whole GPP file in all procedures. So you define it in init post and use it wherever you want. Now you can have also a local variable. Local variables can be used only in the procedure that are defined. So if you define a variable in start of job, you can't use it anywhere else except the start of job. Now, how do you name the variable you define? We have a convention for this because when you have to edit the post that someone wrote in their native language that you don't understand, or name the variables in some random way just for him to know that's time that he developed the post. Let's say he named it x1, x2, x3. Now you have to spend your time and find what he defined as x1, x2, and x3. That causes frustration, causes loss of time because you have to spend the time to find it out. And because of that, we have developed a convention. Now, why do we need it? Like I said, it eases our job. It makes everything more simple. And this convention states that you name the variables in English and use some of the rules that are set. Now, these will be only some first rules that we will need in the beginning of this course, but you will get the whole presentation that states how everything that you defined as a user defined needs to be named. Now, for the variables, we add a prefix to the variable name as by the variable type. For numeric is n, for logical is b because of Boolean, for integer is I, and S is for string. Like you see, after the variable type, you put the underscore and then the variable name with a capital letter. So you see the examples. It is not that easy, but makes the job a lot easier because you know what type of data to expect from a variable when you see it in the GPP file. For user-defined procedures, we just add the @user and then the underscore and then the procedure name again with capital letters. Now, let's just define some variable to give as an example. Now, we see here that we use the user account as the variable to print whose PC is used. Now, let's change that and make a user-defined variable and use it instead. Now, first, let's return the trace level to 1 and save it just to see. We know already where the user account is printed from, but if you didn't know, if we had a procedure for a header or something, we'll go with the trace 1, generate the Gcode, and now see, okay, user is printed from start to file. Now, we go to start to file in GPP. We can see, okay, here it is. Now, we need to define a new variable that will store this data. What this variable is, it's a string. You can see that by using the extension for the GPP editing in SolidCam, or you can use SolidCam help to find out. So you can go to help, SolidCam help topics, GPP tool, and search for any variable to check what the type is. So user underscore account. Okay, let's open this. Let's find, okay, here it is. And type is string. If you didn't have the GPP extension installed, you can check it out like this. Also, you can go by experience and know if it holds any letters. It's a string variable, but just to make sure, you can do this. For anything that is hard to understand in the GPP files, you can always search the SolidCam help, GPP tool help, and check for any explanations there. Everything is well documented and will serve you well. Now let's close help. Let's go back to our GPP file. We know we need a string variable, so let's define. This is for the format, so let's do it here. Let's define a global string, and let's name it by the convention. So we have a string, so s underscore and then a capital. Let's name it user account again, or we can name it cam programmer. So cam, we can go with the underscore or just like this. Let's go with underscore, it's more easier to see. So okay, we have a new variable. It is declared. Now we need to add it some value. How you do that? We will cover the assignments again later, but one important thing to note, when you define any variable, you would think that it comes without any data, so blank, but integer and numeric are 0 when defined. Boolean or logical variables are set to false by default, and string variables are blank. So you have it is not that it doesn't have any data, but it doesn't hold any characters. So if we were to print this, we will get just an empty space. So let's declare the value of this variable. Let's copy it and let's declare it again in the end, in the start of file. So the beginning of start of file. Let's make a new line, use tab, and let's say paste the name as cam programmer is user account. So the value of the cam programmer will be the same as the user account. Okay. Now, if we leave it like this, nothing will happen. We will have a new variable with a value same as user account, but it is not printed anywhere. Now let's change it from, delete it from here and put our new variable. So let's copy its name. Let's paste it here. And now let's save. Okay, let's check. It should be the same. Let's generate a Gcode. Yes, it is the same. But if you were to check and take a look, you would see that in the GPP file, now we have our new variable. Okay, Daniel, I think that will be it for today. If you want to take over.
All right. Thank you, Lukashin, for this great training. It was a very good first step towards the post-processors. We have a couple of questions. I would just say like that one of the questions were something connected that we'll talk about formatting of the variables that we will discuss in the next training. So I will leave that. I didn't forget it. I will not forget it. So for the next training, I will for sure explain it. Another, I would like to say a few things about the procedures. You know, this is the way how I learned it, and I found it on some of the books that were very very nice explanation of, because you know what you are seeing over here right now. I would say that most of the programming language in general have the procedures, functions, variables, these kind of operators that you will see also later on in the training. So it is what you see over here. It's also very similar to the C++. Okay. For all of you who are familiar with this programming language. Basically, I will come back to the procedures. The procedures are pretty simple. As Lukashin already shown, you have the toolpad, and each of the lines represents some of the procedure. I also like to make a funny example of the making a sandwich. You know, when you're making a sandwich, what you have to do, you need to take, you know, the bread, then you open the bread, You put the salad there, you put the burger, you close, you put the ketchup eventually, and you eat. Each of these steps are actually the procedures, and it goes from top to the bottom. You cannot put first the burger and then the bread. So there is a really nice order which the procedure needs to take. All of those, it's actually the system procedures that Vukasin also explained it. That would be for today. I hope that you really enjoyed on this. I really did. If you have any more questions, you're also free to contact the international support team through the email that I will also show by tomorrow for all of you who don't have our contacts. And we'll see each other tomorrow again. Make sure that you all install the Visual Studio Code as we'll go through. I have one more question, I think. Okay, just a second. Can program take from? No. Okay. The question was, can the account name of the PC be the? No, we don't have this variable. We'll show you from which this account name is actually coming from. Maybe it might be a good example that we create a feature request that the account name of the PC would eventually come into a trace. I think this would be a tricky for the software to get this information from the Windows, but we'll see. How the sequence of the procedures from GPP are taken. Okay, Ron, we'll also go through that in the upcoming training. Of course, you can't know in front how procedures will come from the SolidCam. Okay, first of all, you need to understand that in some operations it will go in different order than in another operation, for example. So also it depends on the VMID settings and so on and so on. This is also, it will come eventually, in some future also training, so you will have better overview. It's not for the very first training session, okay? But good question. We'll make sure that we pass through all of this, okay? All right, so see you basically tomorrow at the same time. We'll go through more. And also you should know that we say that it will be 6 trainings. It might be more or it might be less. We just assume, it depends on the many questions and how much we will have received, as we want to make this interact most interactively as possible. So you should all know that if we don't finish something, or we will not just say, okay, 6 session and it's end, but we might also extend for maybe 2 or 3 additional more. It depends of how everything goes. Okay, so I wish you very nice, pleasant rest of the day, and see you soon. Bye.
Bye, guys.